to look at dilations and transformations today. So whenever we're trying to find the scale factor that was used on a dilation, we always have to do our new one over our original one. Now what we can do to be able to compare new over original, we can count our side links here, and we always can identify which one is our new one using this little prime mark right here. So I know that this is my new one, and I know that this is my original. So if I count the length of this new one here is 1, 2. My original is 1, 2, 3, 4, 5, 6. So I know my scale factor is 1/3. And which means it was a reduction. Remember, when our scale factor is less than 1, it's a reduction. When it's greater than 1, it's an enlargement. Now, orientation is talking about how this shape was sitting. So notice that the shape did not turn at all. It did not flip or anything. It is staying in the same orientation. It's staying the same way. So yes, the orientation was preserved. And then it asks about congruence. Congruence means same shape, same size. In this case, it is the same shape, but it is not the same size. So it was changed because we had a reduction. Now, we didn't really go over rotations with y'all. I will show you the rules for rotations here in a minute, but we really didn't spend a lot of time on rotations because it's a lot of information, and it really, it will help you in 2 years in geometry, but it's something that you probably wouldn't remember then. But translations and reflections and dilations are something that will probably stick with you a little bit longer. So whenever I'm looking at this first one, remember, anytime I am adding or subtracting from my x and y, that was a translation. So I know that this translated, remember it slides, it translated. And since I'm taking 5 away from my x, I know x means left or right. So I know it translated left 5. And then that left looks really rough. It looks like a 6. So, okay, it basically went 5 left. And then when I'm dealing with my y, that means I'm going up or down. And since I'm adding, that means I'm going to go up. So it went 6 up. We're not going to worry about that rotation. On C, I know that anytime I'm multiplying something by my x and my y value, that was a dilation. So, and this scale factor is greater than 1. So we know that it enlarged by a scale factor of 1.2. And then anytime my x and my y stay in the same spot, but I take the opposite of one of them, I know that it was a reflection, and the one that stays the same is the axis that I reflected over. So I know that this reflected over my x axis. So down here with transformations, this shows each one of the transformations. Our translation, so like I said, that it slides. So this one slid to the left, and then it slid down to get to my new one. A reflection means that it just flipped over. So I take one and it flips over to the other side. Notice that the little winky part of the smiley face is there. Rotations turn the figure. So notice how this turned up to that. And then dilations either enlarge or reduce the figure, and notice that it reduced. For it to enlarge, my scale factor has to be greater than 1. For it to reduce, my scale factor is less than 1. This gives you each one of the rules and kind of what happens. This little part right here gives you each one of the rules, and it kind of tells you what happens. So like if I'm going right or up, how that will affect what I do to my x and my y. If I'm going left or down, what happens to my x or y. When I reflect over my x-axis, notice my x stays the same. When I reflect over my y-axis, notice my y stayed the same. Your rotations, you can look at these. I'm not going to quiz you over them or anything like that. If you see one on this STAR test, if you're going to take the STAR test, do the best that you can with the rotation. But like I said, the likelihood of you seeing one is slim. And then for a dilation, we always know that we multiply our x and y by each one of by whatever the scale factor is. Again, to find our scale factor, we take our new over our original, or our image over pre-image. So image would be like A prime, and pre-image would be like where we started before. That would be like A. If our scale factor is greater than 1, that makes my shape bigger. If it is less than 1, it makes my shape smaller. Area and perimeter. Remember that my perimeter is affected just by the scale factor alone. Just by the scale factor alone. My area, however, is affected by the scale factor squared. So if a scale factor of 3 will make the perimeter 3 times greater and the area 9 times greater, because 3 squared would give me 9. Congruence and orientation. So congruence means it's the same shape, same size. So that works on translations, reflections, rotations. Orientation of a figure, that only works when the orientation is preserved only with translations and dilations. On each one of these, you're going to go through and determine which of the 3 statements, or there are 3 statements that are correct and 1 statement that is incorrect. You are going to identify the incorrect statement and then tell me why. So you have these to work through. If you have any questions,